Okay, dear students, welcome back once again. After we analyze your essay type question carrying 5 marks, very short answer type questions carried 1 marks, and multiple choice questions 1 marks. Today, let we analyze your questions. Okay, short answer type 2. Okay, carrying the 2 marks. Okay, there are 10 questions. Okay, so these questions are somehow based on your knowledge, and somehow it's based on your understanding. Some questions are very powerful and very strong questions which are very difficult to answer, that are based on the logic. Let me start it one by one. So let me read the question number 15. So you will just take out your question, keep it on the table. See the question number 15. Give two properties that should be possessed by a solution to be an ideal solution. It's very general question. So I think most of you can answer this question, right? So what are the answer? I'll give the many answer, so you just find out what you have written there in your answer paper. So this questions carried 1 mark each of the 2 points, right? So now here just I write this question number 15. So I give it a point number 1. So this point, so it's very important to remember, that is the intermolecular attractive interaction. So here I write in between the component. So I just mention here component. So it can be liquid in the pure state. Right? That interaction is nearly equal to those components in the solution. You can write this point, so that's the very important, I think you haven't read. Then number 2 point, those solutions which always roll slow. That means solutions always roll slow. So let me write here. For binary mixture, if you mention like this, so it can give the marks, right? What the binary mixture say, component A and component B. If you write a component A, so you can write like this. If you write a component B, you can write this. So these 2 points can be right. Besides that, these 2 points you can write the so change in enthalpy of the mixing is equal to 0. You can write change in volume of mixing, that also equal to 0. So these 3 points, 2 of the point you can write it, so you can get a mark 1 each, right? So these are the answer of that question number 15. So I think this question I consider as the easy question, right? Not much difficulty. Every student could remember all these things. I think your teachers haven't taught you. Then question number 16. Ozone in the atmosphere, that is the stratosphere, is decomposed by nitrogen monoxide in an elementary reaction given as O3. That is the reaction. Plus NO. O2 plus NO2. So this is the reactions given there. So number one should remember that elementary reaction. Okay, write the rate law and predict its overall order. See this chemistry, okay, this equation, okay, so requires, okay, very strong understanding of this reaction. Okay, so it's very confusion what will be the rate law and what will be the overall order. Here the chemistry in this stratosphere, right, this ozone decompose into the oxygen in presence of the NO. See this nitrogen monoxide, okay, reacts with the NO, I mean O3 ozone. It forms the oxygen plus NO2. Here, okay, so the decomposition of the O3 into the O2 depends upon the concentration of the NO, right? So in the presence of the NO, this O3 can be decomposed into O2. Therefore, this NO playing very important in this reaction. Therefore, so the concentration of the NO is also depends on the rate law. Therefore, what should be the rate law? See, in this reaction, elementary reaction, what is the stoichiometric ratio? Here is the 1. Then what is the coefficient? 1. That means how many oxygen ozone here? 1. How many number of the moles of the NO here? Also 1. See, so when we write the rate law, so what will be the rate law? So rate law, that means rate equation. We write rate equation. Here K is the rate constant. So in our rate equation, the rate of the reaction is depends on the concentration of the O3. So I write O3. What is the coefficient? 1. Then and the rate of the reaction also depends on the concentration of the NO. So we write NO also. What is the coefficient here? 1. So what will be the power here? 1. What is the power here? 1. So this is the rate law, right? Then now let me find out the overall order. So here the second answer is order with respect to O3, that is the first order. Second, overall order with respect to NO, that also first order. So what is the overall order? So that should be 1 plus 1 is equal to 2. That is second order. So this should be the answer of this question, right? Okay, so I hope you have been written in your answer paper, right? So this question I consider as a very strong logic, and somehow it's difficulty to answer some general students, right? Okay, question number 17. Concentrated aqueous ammonia contain 1.00 moles ammonia dissolved in 2.44 mole of water. Calculate the molar concentration of the ammonia solution. So this question also I consider it's not much difficulty level, so it's a very general question. So we know the K concentration. Whatever concentration, that is the molar concentration, means molarity. How do we calculate the molarity? So as we know, the molarity can be calculated, that is number of the moles. What is the solute present here? Ammonia. Number of the moles of the ammonia, divided by the mass of the solvent. So we have to calculate in the kg. Right. So number of the moles of the ammonia is given here. How many moles? 1.00 mole. But number of the moles of the water is given here. How much? That is 2.44 mole. But here, so the mass of the water is not given. So from the given number of the moles, how do we calculate the mass of the solvent, right? Water. That means number of the moles, that divide mass of the mole divided by molar mass. So what is the water? And this is also water. So that will be the water. What is the molar mass of the water? That is iodine. So if we are going to calculate, mass of the water, that is equal to number of the moles of the water multiplied by the molar mass of the water. How many moles? That is 2.44 into what is the molar mass? That is 18 grams per mole. So this is the mole. So mole can be cancelled. So what will be remain here? So 2.44 18 grams when you did calculate. So that will be how much? So you can calculate. Then after that you find this answer value. So I write 2.44 multiplied by 18. So 8 4 are 32 and 3 8 4 are 32, 32, 35, 2, okay, 3, 8 to 16, 16, 17, 18, 19, right? Then is 4, 4, then 2, right? 2, 9, that will be 3, and that will be 4. So what will be this? 43.9 gram. This should be gram, right? That means I write here that will be 43.9 gram. So approximately can we write 44 gram. Let us take it here. So after we found a 44 gram, so we can put it here. So here molarity is equal to number of the mole is 1.00 divided by 44 grams. So we are going to calculate in the 1 kg. So we multiply here 1000. That means 1000 divided by 44. So how much should be here? I think 22 point something, right? That is the molar. This should be the answer, right? Okay. So I think this question is not much difficulty. I think okay, all of you can understand how to calculate this question, right? The next question is question number 18. Mention a factor number 1 which affect the rate of reaction as well as magnitude of the rate constant. Number 2, which affect the rate of the reaction but not the magnitude of the rate constant here. So this question is based on your knowledge, right? So it's from the your characteristics of the our important factors affecting on the rate of the reaction and the characteristics of the rate constant here. So that's be given in your book very clearly, right? So regarding the rate of the reaction, regarding the rate of the reaction, what are the important factors affecting on the rate of the reaction? So let me write the number 1, concentration. That's the very important. Number 2, temperature. These two factors are very important now here. So rate of the reactions are depends on concentration of the reactant, and the rate of the reaction is also depends on the temperature. But how is the rate constant? Here, when you study about the characteristic of the rate constant, right? So rate constant, value of the rate constant, it depends on temperature. Remember, right? But the value of the rate constant does not depend on the concentration. Not depends on the concentration, right? So these are very important factors which are related to rate of the reaction and rate constant. So answer 1. What will be the answer 1? So affect the rate of the reaction as well as the magnitude of the rate constant. So that will be the temperature, because temperature here also, right? Number 2, which affect the rate of the reaction. So concentration is affected on the rate of the reaction, but so that factors does not depend on the rate constant. So here it will be the concentration. So this is the answer which can write. That means you can write here temperature and concentration, but in the case of the point number 2, it should be right only the concentration. So these two will be the answer of this question, right? So I think it's not much difficulty. So all of you can answer this question, right? question number 19, right? Explain with a suitable example the process of vapor phase refining, right? Question number 19. So this question also came based on your knowledge, okay? So when we prepare for our examination, after we go through the or textbook, I think you can answer it. So this vapor phase refining, okay? So how will be this? Okay, what will be this? This is the conversion of, okay, our impure metal into, okay, pure metal. Okay, so that, okay, refining of the our impure metal. So this, okay, in what a conversion here, so that conversion of the impure metal into the pure metals. So what is the first steps of conversion is converted into the volatile compound. So what is the first? That is the conversion of impure metal, okay, into, okay, vapor, okay, that means, okay, volatile, we can say the volatile compound with suitable, okay, reagent, and then decompose into pure metal. So this is the method which we follow, okay, by the vapor phase refining. So example, we can write examples. We have two examples. One is the Mond process for refining of nickel, Mond process for refining nickel. So what is the reactions given here? So nickel, so reacts with a carbon monoxide. So it form, okay, the volatile compound. So nickel tetracarbonyl. So here is the temperature. So this is the first step. So this is the volatile compound. So this number 2 step, that is nickel carbonyl. So heated at high temperature 470 Kelvin. So this volatile compound is converted into nickel. This is the pure one and carbon monoxide. So this is an example. So you can write this example, or you can write another example that is called Van Arkel method for refining zirconium or titanium. So this example, I think, is very easy. I hope you can write, okay, in your examination. Right. So this question, I think, is also, okay, part of your knowledge. Right. The next question, number 20. So this question also, I think, I consider is the as equation. Not much difficulty. It depends upon your level of the knowledge. So why are interhalogen compounds are more reactive than the halogen? Very common question. So everybody, so I think, okay, all of you will be prepared, okay, in your examination. That means interhalogen compounds are, more reactive than the halogen, because what? So because means, okay, bond, okay, between interhalogen compound, okay, weaker than, okay, bond between between the halogen itself. So this is the simple answer you can write in your exam, right? So write product form when ClF undergo hydrolysis. When interhalogen compound undergo hydrolysis, so different product will form depending upon the types of the interhalogen, the number of the halogens present here. That is the hydrolysis of ClF, right? So what will be the product? ClF, when we react with water, what will be formed, right? See here, this hydrogens react combine with F, is formed F, then remaining H and one oxygen, that will be compound like this. This is the hypohalite, so this is the product, so you can write, so it's given very clearly in your textbook, right? So this question, I think it's not much difficulty, it depends on your level of your knowledge. So I hope you can answer it, right? Then question number 21. Question number 21. This is question from the organic chemistry, right? Here the question is, so how would you convert benzene diazonium chloride to benzyl amine? So let me write the reaction directly here. This is the benzene diazonium chloride converted into benzyl amine, right? I just write here CH2 and H2. This is what we call benzyl amine. So this is the benzene diazonium chloride. So we have two options. So mark carried I think 2 marks, so we can write the 2 steps here. So first step, there is no any but we have a direct reaction also, we have another indirect reaction also. We have a 2-step reaction. So first, this benzene diazonium chloride can be converted into how we converted this reaction. So the reagents we can write copper cuprous cyanide in presence of copper powder. See, I hope you remember that in the preparation of the haloarine. So I think you remember the SIRNdemy reaction. In that SIRNdemy reaction, so we study about this reaction here. So now here, so this benzene diazonium chloride reacts with cuprous cyanide, it converted into the benzonitrile. So this benzonitrile undergo reduction. So we can have the reduction. How will we write a reduction? So here, this is the C triple bond N. So this is the benzene ring. So here this C double triple bond N undergo the reduction means addition of the hydrogen. We can add a hydrogen. So in order to add the hydrogen, we require the reducing agent. What are the reducing agents? So I write here some reducing agent. So renin-nickel, one of the very important reducing agent. If you write this one, so you can write this one, or you can write some common reducing agent, lithium aluminum hydride. So this can be also write here. So either this one or this one you can write it. Then after that we'll write this compound C H2, then NH2. This is the benzyl amine. So you write these steps. So for this 1 mark and for this one. So this is the answer of that question, right? Next, what is peptide bond, right? So I think it's also very easy. So you can write what is the peptide bond. Okay, question number 2. This is from the biomolecules, right? So peptide bond. Okay, so bond. Okay, present. What type of bond? It should be present with this. Right? So the bond, I mean the chain, okay, the compounds containing this bond, I mean C double bond, N has unit. This is called what? A peptide bond. Right? So I think in your examination write it here. So how many peptide bonds are present in a tripeptide? See, tripeptide bond, I mean tripeptide chain can be formed by the 3 amino acids, right? 3 amino acids. See, in between the 2 amino acids, so one amino acid here, another amino acid here. So in between the 2 amino acids, one peptide bond is here. If you take a 2K, I mean 3K3, I write A, B sheet. Okay, in between, suppose this is one of the amino acid, this is another amino acid. In between the 2 amino acid, one peptide bond should be there, and in between these 2 amino acid, another peptide bond should be there. So in between these tripeptide means 3 amino acid. Okay, so in a tripeptide chain, how many peptide bonds should be there? So one should be here, another should be here. That means how many should be there? That should be the answer is 2. That means how many peptide bonds are present in a tripeptide? The answer will be this question number 22. Number 1 answer is the bond, that is C double bond oxygen, and is bond, that is the peptide bond. How many should be there in the tripeptide? That should be right 2. Answer is 2. Right. Then question number 23. This is from the biomolecules. I mean it's from the carbohydrates, right? This is the question number 23. Now, so cellulose and glycogen are the polysaccharides, right? Okay, you please remember that. So what's the difference between the cellulose and glycogen in terms of the monosaccharides? Okay, monosaccharide. So cellulose also, okay, cellulose and glycogens both are polysaccharides. Okay, that polysaccharide means polymers, right? Okay, so the monosaccharide unit are same, all these glucose unit. This is the first answer, glucose unit, right? The answer in second, number 2, linkage between the units. So what is the name of the linkage? That is the glycosidic linkage. Glycosidic linkage. Glycosidic linkage. So, but in cellulose, so these glucose units, okay, these glucose units are polymerized. That means joined together, right? So through the bond, what is the name of the bond? That is the glycosidic linkage. So in the glucose unit, so number of the carbons there. What are the carbon units? They use it in cellulose. Okay, in cellulose, what is the glycosidic linkage? That is the C1 and C4, right? But what type of the glucose? We have two different types of the glucose. One is the alpha glucose, another is beta glucose. But in cellulose, what is the glucose? That is the beta glucose, right? But in the glycogen, right, what is the glycosidic linkage? That also C1 and C4, but the difference is one above one is the alpha glucose, the below one is the above one is the beta glucose, the below one is the alpha glucose. That's the difference between our cellulose and glycogen. So that's only the knowledge what we have, right? So this is the answer of the question number 23. So during the class, I strongly remind you. So you please remember all these the glycosidic linkages, right? Okay. Last question for this types of the question. Okay, I mean carrying 2 marks. That is question number 24. So represent the polymer formed by the monomers, right? Monomer is given here. One is the lactic acid and number 2 is the propylene. So this question also, it's not much difficulty. So as we know the monomers given, so how we form the polymer? So that means these monomers are joined together. How these monomers are joined together? Number 1, that is the lactic acid, right? How to write the lactic acid? So now instead to write this structure, let me write like this. See, this is the same thing, right? But now here, these monomers, okay, that means this monomers join with the another this monomer, right? How it form? So here. So from this so this one let me write like this, right? So here this OH and this hydrogen we remove as a water. Now what do we form here? So it form, so similarly when we form the chain, so this OH is removed, so or from this part this OH is removed, so this hydrogen is removed, so it started form like this. Okay, CH, it forms CH3, then C double bond oxygen, oxygen, then again CH, now CH3, again C double bond oxygen, so it forms like this. So it can form the chain, very long chain it can be formed. So number of these monomers present here. So these types of the polymers it form. What is the name of this compound? That is the lactic acid. If form the number of the lactic acid, this is the polylactic acid. So this is the, okay, we write, okay, in a very simple form, okay. So I think it's not much difficulty to write, okay. Number 2, very similar one, and number 2 also. Number 2, that is the propylene, okay. Propylene. CH3, CH2 double bond, CH3. Now here, see this double bonds, okay, can be form the chain. So now how to write the chain? So let me start from here. CH2, again CH. So it's double bond, now it converted to single bond. Now let me write CH3. Then again C here. Then now again CH2, again CH, right, CH3. Then now it formed the long chain, right, like this. So that means number of this can write it and form the number of this, I mean very long chain. So how many these monomers present, that is another case, but it form the long chain. So poly means many, so how many? So that means polypropylene. This is the polymer we can write. So these are the question, these are the answers, so which can rewrite in your answer paper. So you check it your answer, okay, what I given to you. So I think this short answer type 2 questions not much difficulty. So but somehow we require some knowledge. So I think so everyone, I think all of you can answer all these things, right? Okay, so thank you very much, and on next day, on the next let we analyze your sort of answer type 1 carrying the 3 mark on next day, right? Okay, check it your answer with my keys. Okay then.